So once again, my Zoom session did not record, so I'm going to go back through this video with you guys, or go back through this slideshow of stuff that I went over, and see if I can then post this. So I'm going to go over some of the questions from the review. I'm not going to go over all of them, but I'm going to go over some of them, the ones that I was asked the most questions about. So number one says, Travis's collection of DVDs contains 14 comedies, 12 dramas, and 10 action movies. Find the following probabilities. So the first one says randomly selecting 3 comedies without replacing between draws. So the very first thing we need to do before we work any of these problems is add together the 14, the 12, and the 10, because that's going to tell us what our denominator is going to be, what's on the bottom, okay? So that's 14 and 12 is 26, plus another 10 is 36. So we know that's going to be our denominator that we're going to start with in all of our problems, okay? Then it's asking us for 3 comedies. So, and it says that we're not replacing. So my first question for you guys is this problem an independent or dependent probability? It's dependent. Why is it dependent? Because the number of that we started with 36 is going to go down every time we take out one of the DVDs. And in this case, because we're pulling 3 comedies, that 14 is going to decrease every time we're pulling out another comedy, because we're not replacing it. We're not putting it back from where we got them, okay? So our first one is going to be 14 over 36. That's how many comedies there are, 14, and then our total was 36. Our second one would be 13 over 35. Again, because we took out one of the comedies, we didn't put it back, so now there's only 13 left, and there's only 35 left. And if we pull one more, there's only 12 left in wherever we're getting them from, the shelf, whatever. And there's only 34 total left. So what do we do here then? We multiply across the top. We get 2184. We multiply across the bottom. We get 42,840. And then this would be written as a reduced fraction. And when y'all are taking the test, the answers could be as a reduced fraction, they could be as a decimal, or they could be as a percentage. So make sure you read how you're supposed to write the answers, okay? So part B here says randomly selecting 3 dramas with replacing them between each draw. So that means we start with 36 here, but if we take one away and we put it back, it still remains 36. This also says 3 dramas. So we had 12 dramas, so this problem right here is going to be independent because we replace between each draw, okay? We have 12 dramas. We're going to put 12 over 36, but we're going to put back that one drama that we did, and we didn't affect the total then, so it's going to be 12 over 36 times 12 over 36 times 12 over 36, and that equals 1728 over 46,656, which again reduces to be 1 over 27. Remember, when you have and statements, we're multiplying, guys, okay? When we have or statements, we're going to add and subtract the overlap. All right, so that C here says randomly selecting 3 action movies without replacing. So those words right there tell us whether it's dependent or independent. Our number's going to stay the same throughout the whole problem, or are they going to change? Without replacing means that this is dependent because we're keeping some things out. We didn't put them back, right? So action movies, we have 10 of those. Again, our total is 36. So our first action movie probability, and this would be dependent again, would be 10 over 36. Our second would be 9 over 35. Notice again that both the numerator and the denominator are decreasing. And then 8 over 34. Again, multiply across the top and across the bottom. That reduces to be 2 over 119. All right, our last one here for number 1, randomly selecting 3 movies that are not dramas and replacing between the draws. Okay, so if we're replacing again, this is going to be independent, like it was up here for letter B. And how many movies are not dramas? Well, we have 12 dramas. We had 36 total, so we subtract 12 from 36, or we add the 14 to the 10 because those are the movies that are not dramas, so that would be 24. So this time we are replacing between draws, so we're going to do 24 over 36 times 24 over 36 times 24 over 36. Again, multiply across top and the bottom, and that reduces to be 8 over 27. All right, number 3. I skipped number 2. If you need number 2, then watch the video for the review, okay? This says a grab bag contains 7 football cards and 3 basketball cards. How many total cards do we have right now, y'all? You're right. 10. Because we're going to add the 7 to the 3. Remember, that's always going to be our denominator. It says an experiment consists of taking one card out of the bag and then selecting another card. What is the probability of selecting a football card and then a basketball card? This is an and probability. So the first card is not replaced. So if it's not replaced, this one's going to be, you got it, dependent. Over here, B, it says the first card is replaced. So this one is going to be, yes, independent. Okay. So this can be dependent. We're talking about football and basketball. And this one's going to be independent, and it's football and basketball. Okay. So we're going to take the 7 football cards over the total, which was 10. And then we're going to take the 3 basketball cards. Now, we still had 3 basketball cards in the bag, right? But we kept the football cards, so now there's only 9 cards. So we're going to, again, multiply across the top and the bottom, get 21 over 90, which is 7 over 30 reduced. Again, remember, your answer could be represented as a fraction reduced, as a decimal, or as a percentage. So over here, this one says independent. The first card is replaced. We're doing the same thing. We're doing football and basketball, right? So we've got 7 over 10 this time, and then 3 over 10 because we put the card back, right? So again, we're going to multiply across the top and the bottom. 21 over 100, which is 0.21 or 21%. Okay, number 5. I'm going to show you 2 ways to do this problem. The table shows the distribution of male and female students and left and right-handed students in the math club. Make a table of the joint and marginal relative frequencies expressed in decimal form. We're going to do that second, but first I'm going to show you the easy way to do this problem, okay? So we're going to find the total number of people in the survey. So we add all our numbers together and we get 79. So, and we're going to add across this way. So now we're going to create another table. And we're going to add across this way and across this way and across that, and up and down. So we're going to add our columns and our rows, okay? We know that this number down here is going to have to be 79 because that's how many total were in the survey, right? So we're going to add 2 to 35, that's 37, 6 to 36, that's 42, 2 to 6, that's 8, and 35 and 36, that's 71, okay? So now I'm going to answer these questions here based on just this table that we just created. It says, given that a person is left-handed, what is the probability that they are female? So we're looking for a total here. And that's what we're going to put in our denominator. It says, given that the person is left-handed. So are we talking about a row or a column of left-handed people? Yep, you're right. So we're talking about that row right there of left-handed people. Then how many of those total 8 people were female? Well, 6 of them, right? So what we're going to do is put the 6 over the 8. That's 0.75 or 75%. All right, and then the next one says, given that a person is male, again, so we want to look for a total of males. That's what we're going to put in our denominator. What is the probability that they are right-handed? So this time, are we talking about a column or a row? Right, we're looking for that row right there. So this time, we're going to put this 37 in our denominator. And how many of those males were right-handed? 35 of them. So we're going to put the 35 over the 37. That gives us 0.947 or 94.7%. Okay, now here's the other way to do this, okay? Once again, we're going to create our table. Now this time we're going to figure out the percentages in each box, right? So in this time, we're going to take all these numbers and divide them. So we're going to divide the 2 by the 79, and that gives us 0.25. The 6 by the 79, the 35 by the 79, the 36 by the 79. That's going to give us all these probabilities right here, these percentages, right? Then we're going to add again our rows and our columns to get our totals, okay? We did this before. Now the only difference here is that when I add these 2 numbers together, they should equal 1, and I add these 2 numbers together, they equal 1, because these are percentages, right? So when I do this problem, I'm going to do it the same way I did the last one. We're talking about, again, left-handed. That's that column. So we're going to take this total, and we're going to put 0.101 in the denominator, and we're going to pick the 0.076 and put it in the numerator. That's going to give us, again, about 75%, okay? It's a little more accurate just because, why? Because we have 3 decimal places here, okay? Then it says, given that a person is male, again, what are we talking about? All our males, total males. That's going to be that number right there, Okay, that's going to be our denominator. How many of those are right-handed? The 0.443. So once again, we're going to divide 0.443 by 0.468, and that gives us 94.7%. Okay, our next one. There are 5 nickels, 3 dimes, and 5 quarters in your pocket. You randomly pick a coin, find the probability of a nickel or a dime. You guys got to know that this is the or symbol. And the one that looks like an A is an and symbol, okay? So ors mean that we are going to add, and we're trying to determine if something's mutually exclusive or inclusive, right? So the question is there overlap in the groups? This says there are 5 nickels, 3 dimes, and 5 quarters in your pocket. So how many total coins do we have in the pocket? 5 plus 3 is 8, plus another 5 is 13. So there's a total of 13. And then it says, find the probability that's a nickel or a dime. So how many nickels do we have? Well, first let's talk about this. We're only pulling one coin. Is there any, can I pull more than one? You're right, the answer is no. So I can't pull a nickel and a dime at the same time if I'm only pulling one coin, right? So this is going to be mutually exclusive, okay? Because there's no overlap. So then we're talking about how many nickels? 5 over the 13, right? And then we're going to add to it the number of dimes, which is 3 over 13. Should I say 13? Sorry. 5 over 13 plus 3 over 13, that's 8 over 13. And if I divide that 8 by 13, I get 0.6154, 61.54%. Again, remember, the answer could be represented in any of these 3 ways, so you guys got to read the questions on the test. The jar contains 5 blue marbles numbered 1 to 5. The jar also contains 7 red marbles numbered 1 to 6. You randomly pick a marble. So we've got some red and some blue marbles, right? So let's see, we've got 1 through 5, it says 1 through 5 blue marbles, and then 1 through 6 red marbles, right? So I'm going to go ahead and circle all, or I'm going to basically square out all the red right there, and then I'm going to circle all the odds here. So I don't know why it's doing this in random order. There it is. There they are. Okay, so we've got 6 red, right? So that's going to be our 6 over our 11, and we've got 11 total because 5 plus 6 is 11. And then we've got 1, 2, 3, 4, 5, 6 total that are odd. But then right here's our overlap. We counted this 1, 3, and this 5 twice, so we had to subtract them. So that's why we're subtracting the 3 over the 11. So that's 12 minus 3, which is 9. 9 over 11 is 0.81. 81, which would be 81.82%. So this is an inclusive problem because we have overlap right here, okay? All right, number 10 says there are 10 shirts in your closet, 3 blue, 3 green, and 4 red. You randomly select one to wear, okay? Find the probability of blue or green. Again, this is going to be a adding together and maybe subtracting if there's some overlap. It says there are 10 shirts in your closet, right? So we're going to put whatever these numbers are over 10. It says you randomly select one to wear. So let's kind of draw this again. So I got red, 3 blues, 3 greens, 4 reds, right? So it says blue or green. So if I choose a blue or I choose a green, there's no overlap there. Do y'all notice that? We're only pulling one at a time. So this is going to be a mutually exclusive problem, okay? So all we have to do here then is find out what is the probability that I pull a blue, and we had 3 blue, so we're going to put 3 over 10. We're going to add to it the greens, which is also 3 over 10. So we're going to add, that was our total, by the way, 3 over 10. Add the 3 over 10 plus the 3 over 10, that equals 6 over 10, which reduces to be 3 over 5, excuse me, which is 0.6 or 60%. All right, number 11 says a bag contains 6 yellow jerseys numbered 1 through 6. The bag also contains 6 purple jerseys numbered 1 to 6. You randomly pick a jersey. Find the probability of yellow or odd. So again, I'm going to draw this. So I've got 1 through 6 in yellow. So now this one says yellow. So I'm going to box out those yellows. And then it says odd. So once again, I'm going to circle all my odds. Right? So when I do this, find again that I can say that I got 6 out of my 12, and I know that there's 12 because 6 plus 6 is 12, right? So this is going to be inclusive because we see the overlap, right? So we got 6 over 12 because that's how many are yellow. And then we're going to count again, 1, 2, 3, 4, 5, 6 total that are odd. But here again, we've counted this 1, 3, and 5 that are yellow twice. So we have to subtract them, the 3 over 12, right? So we're going to add 6 plus 6, which is 12, minus 3, which is 9. So 9 over 12 reduces to be 3/4, which is 0.75 or 75%, okay? All right, number 12. A cooler contains 15 bottles of sports drink, 5 lemon lime flavor, 5 orange, and 5 fruit punch. You randomly grab a bottle, then you return the bottle to the cooler, mix up the bottles, and randomly select another bottle. So this is lemon lime and lemon lime. So this is an and problem, so we know that we're going to be multiplying. And this is either going to be independent or dependent. Now it says that we're returning the bottle. So we started out with 15 bottles, right? So if we return it, is that number going to change? No, it's not, right? So what's the probability that I pulled a lemon lime the first time? It says there are 5 lemon limes, so it's going to be 5 over 15. And then we're going to multiply that by 5 over 15 again, because we returned the bottle, right? So 5 over 15 times 5 over 15 is 25 over 225, which again reduces to be 1/9. And again, recall, this could ask for it as fraction form, decimal form, or percentage. Number 13 says a basket contains 6 apples and 6 peaches. You randomly select one piece of fruit and eat it. Then you randomly select another piece of fruit. Find the probability of an apple and a peach, right? So here we go again. Let's figure out how many we have total. So 6 plus 6 is 12, right? You randomly select one piece of fruit and eat it. Then you randomly select another piece of fruit. So how many apples did we have? That would be 6 over 12, right? So this is going to be a dependent problem. Why? Because we ate the fruit and it's not going back in the basket, right? So 6 over 12 times what? How many peaches do we have left in the basket? 6, but how many total pieces of fruit do we have left in the basket? Only 11, right? So it's going to be 6 over 12 times 6 over 11. Again, multiply across the top and across the bottom. Reduce. And if you guys don't remember how to do this, you do it on your calculator by pushing math and 1 or math and enter. And that's how you can reduce the fraction, okay? Or if it's in decimal form, that's how you can turn it into a fraction, okay? All right, so number 16 says a box contains green and red apples. 3 apples are drawn without replacement. The probability of selecting, now I changed the order of these words red and green in this problem because the way it was written, we couldn't do it. So you guys might want to go in and change the words in here. This was green and that was red, and so I just basically changed most of the words from red to green, okay? So it says the probability of selecting a red apple and then a green apple is 0.24. The probability of selecting a red apple on the first draw is 0.43. What is the probability of selecting a green apple on the second draw if the first draw was red? So this is going to be a conditional probability problem. Probability of A given that B has occurred. So that's when we do the probability of A and B divided by the probability of B. And this is on your formula sheet, okay? So what we're going to talk about is what's the probability that we pull a green apple on the second draw if in the first draw the apple was red, right? So that's just the probability of red and green, which was up here, red and green. Y'all see this up here? It's 0.24. And then what was the probability that it was a red on the first draw, right? So that's 0.43. So we're going to divide the 0.24 by the 0.43, and that gives us 0.558 or 55.8%. Number 17 says, assume the following events are independent. The probability that a student takes the AP Human and AP Biology is 0.45. The probability that a student takes AP Human is 0.85, which is the probability that a student will take AP Biology given, again, that the student has taken the AP Human. So once again, we're talking about a given probability. A given B has occurred. So we're doing the probability of A and B divided by the probability of B, okay? So that means we're going to take the probability of AP Bio given that they've taken AP Human, right? So we're going to take our and probability, which is this one up here, and 0.45, and we're going to divide it by our AP Human probability, which is our 0.85. When we do that, we get 0.4529 or 52.9%. Okay, number 18. As in a neighborhood, 2/3 of the residents voted to plant daisies in the front entrance. 5/8 voted to plant daisies and daffodils. what fraction of those that vote for daisies also vote for daffodils, okay? So on this one again, it's asking us, given that something occurred, what is the outcome? So we're talking about what is the probability that we have daffodils given that daisies are planted, right? So we're going to do the and on top again and divide it by the individual. Now this time I want to tell y'all, if you guys will do this on your calculator, you can put the 5/8 in parentheses and just divide it by the 2/3. Again, remember, if you get a decimal, which you would get this, and you want in the answers are in fraction form, push math 1 on your calculator, math enter, and it will give it to you in fraction form, okay? All right, this last one. A group of 44 students who are animal lovers were surveyed to determine which of the 3 types of animals they own. The Venn diagram has the results of the survey. Using the Venn diagram, find the probability of the problems below. Okay, so it's actually to the right for us because I moved it. In OR problems, you can add the numbers that are in both circles and put the number in the numerator and the total in the denominator. So we know that there were 44 total students, right? So we know that that's going to be our denominator no matter what we're doing, okay? Then what we want to do is look at these. So we're looking for the probability of a cat or a bird. So cat or bird. So all we have to do is add these numbers together. 10 plus 10 plus 6 plus 2 plus 2 plus 1. And put those numbers over 44. That's really how simple it is, y'all, when it's an OR statement, okay? Then we got cats or dogs. So again, we're going to add together everything in this green circle and the blue circle. 10 plus 10 plus 6 plus 2 plus 9 plus 2. Put that all over 44. That gives us 39 over 44, or 88.64%. Our last one was dogs or birds. So again, we're going to add everything in this blue circle and this pink circle. So we can go 1 plus 10 plus 2 plus 2 plus 9 plus 6, right? That's 44. And put that again, I'm sorry, that was 30. And put that over our 44. Again, that reduces to be 15 over 22, or 68.18%. Our next ones are AND problems. So it says in AND problems, you find the overlapping numbers and add them together and put that number in the numerator and the total in the denominator. So once again, we're still going to put the 44 in our denominator, but now all we're looking for is the overlap. So if we say cats and birds, we're looking at cats here and birds here. So we're looking at 10 and 2, right? So that's going to end up being 12 over 44, which reduces to be 3 over 11, which is 27.27%. Then we've got cats and dogs. So here we go. Cats and dogs, the overlap there is this 6 and 2. So we add the 6 and 2, that's 8. 8 over 44 reduces to be 2 over 11, which is 18.18%. Last one, dogs and birds. So we're talking about dogs here and birds there. So there's our 2 plus 2, that's 4. 4 over 44 is 1 over 11, which is 9.09%. So if you guys have additional questions, you need to email your teachers either through Remind or through their email accounts. There are 2 more Zoom sessions today. Miss Viad is having one at 10:30. Hers is actually a Google Meet, and then Miss Audrey is having one at 1:30 today.